Here we are demonstrating UWB radar for detection of human behind the wall. So using Raspberry Pi, we are going to execute this project. So which is the main brain of our system, and Arduino will acting as the output module in our project. Means we are going to send the UWB, means ultra wideband signals that will be generated by this Raspberry Pi 0W. The signals are given as input to these two copper coils. So we have mounted in the PVC pipe, and from there we are going to get the signals of UWB signals of 10.5 gigahertz of signals. So here we are using the multiple sensors to detect the reflected these waves from the passive rays. Means only live human being body can emit the passive rays, and that rays will be reflected these 10.5 gigahertz of signals, and that will be received by this reflected rays will be received by these 5 sensors we place along with the one 10.5 gigahertz signal here. So whenever the passive rays are detected or reflected 10.5 gigahertz signals are received by these sensors, then our Arduino will get the digital signals from these sensors, and whenever the so-called motion detected or reflected rays are affected, then the system will intimate on the LCD along with audible alert through this buzzer as the motion detected. So this detection can be done inside a room or behind the walls, because it won't detect only the persons behind the wall or only the persons in front of this system. So totally it can detect the human beings motions inside a room around of 10 to 15 feet of distance, and behind the wall maximum of 1 meter of distance if the person behind the wall. So only 1 meter can be scanned, and inside this room means we place this kit in a room, and from there as a diameter of 10 to 15 feet of circle, the system can detect the motion. Means if we stand in front of this device without any motion, then it won't provide the alerts as a motion detected. So if you move the motion, for example I'm came in front of the system, then when I'm coming to this near to the system, then it will detect that either from the behind the wall or directly near to the system, then the motion will be detected alerts. So after reaching near to the system, if we don't make any motion, so like statue kind of stand in front of this or behind the wall, then after around 10 to 15 seconds of duration, then the system will make it as a everything is normal. So after that, if you make any motion, then again it will detect as a motion detected, and that alert will be announced from this buzzer as well as from the LCD. So this is the working of this project. Coming to the working principle, so we are providing 230 volts AC input to this, and that will be converted into the DC with the help of rectifier and filter, and that will be converted into again 5 volts to buck convert. Using this buck converter, that's LM25966, we are going to get the 5 volts of DC. Means here 230 volts AC inputs and 12 volts of AC, and output of this rectifier and filter will get 12 volts of DC, and that will be buck to the 5 volts of DC with the help of LM256 voltage regulator. So from there, this 5 volts of DC is the main power source to this antennas. Means we are going to convert this 5 volts of DC to 5 volts of 10.5 gigahertz AC signal, and that will be done with the help of our Raspberry Pi 0W. That signal is input to this H bridge as well as to this timer circuits. Okay, so here is a dual timer and one is a single timer circuit. So we are going to get the signals. So from there the signals will be input to this one, and again receiving signals also will be given to this timer circuit to convert that AC signal to the digital signal, and that will be input to our Arduino at A0, A1, A2, A3 pins respectively from the sensors, and same signal based on this A0, A1, A2, A3, A4, A5 pins, total 6 pins, and output is to the buzzer at pin number 10, and 2 to 7 is a LCD. So this is the input from the Raspberry Pi to the antennas, and output from the sensors to this Arduino Uno board through this converter circuits. So this is the flow of the project. Okay, and let us check with the demonstration. So when on the power supply, so already the motion detected as in front of this one. So right, again motion detected. So wait for some time without any motion. Right, I'm not doing any motion here. So if I make motion here again, so the system will detect that again. Right, okay. So this is the in front of the sensors I'm keep on moving in front of this one. That's why it's getting the motion detected on the LCD and will provide us the audible alert. So if any single motion also detected, so it's continuing providing the alerts. And now let us check with this to detect the pulses behind the wall. So let us make arrangement over here. So right, there is no motion as the buzzer is off. So I am making motion over here. So buzzer is on. And as I said, you can see the one person is behind the wall. Right. Ashwant move. So he moved and getting the buzzer. Again he's moved, right. Come inside. Right. Okay. So I can stand there. Aduguchu. Shut up. So as of now there is the motion here. So that's why no buzzer alert. So if I do any motion, simple motion, again motion detected. So like these signals are totally distributed over here. So in that, if there is any distribution in the distributed signals, if there is any disturbance occurred, then it will get the disturbance and provide us the audible alert to the buzzer continuously. So if any motion continuously is there, keep on providing the audible alert. Again stand by some around 10 to 15 seconds duration. You can see that. Stop, buzzer. Like this. Okay, thank you.